Hello to all of you. This is Dr. Dhaval Maheta, and today we are going to talk about finite mixture FIMIX model in SmartPLS-4. In any data, there consists of two types of heterogeneity. One, the observed heterogeneity, and another one is a unobserved heterogeneity. The observed heterogeneity is the researcher is aware about the observed heterogeneity where at the time of filling up the questionnaire itself. Say for example, the observable characteristics such as gender, age, or country of origin can introduce the heterogeneity in our data set. Or we can say that the model can be different according to the gender, the satisfaction affecting the loyalty in any company may be different according to the small scale size industry or the large scale industries. So the researcher can use these observable characteristics to partition the data into a separate group of observations and carry out group specific PLS-SAM analysis with regard to customer price versus quality consciousness. How to tap the observed heterogeneity and how to create the two different models we have already seen in multi-group analysis, and we had also studied the MICOM. I request all my viewers to kindly refer my previous video to understand the flow of this entire lecture series. The second type of heterogeneity is unobserved heterogeneity. In this case, the researcher is completely unaware about the groups which may be affecting the model. That is completely undetected. The groups are undetected. And the researcher is not aware at the time of filling up the questionnaire that these two groups can have a separate model. So here, the unobserved heterogeneity emerges when the difference between two or more groups of data do not depend on specific observable characteristics. Now, what is this observable characteristics? You have to remember this. The observable characteristics are, we are aware of from day one that my model can be different according to the gender, according to the age, according to the occupation, according to the industry. These are observable characteristics. The unobserved characteristics, the heterogeneity emerging from unobserved characteristics is known as unobserved heterogeneity. Now, how to tap this unobserved heterogeneity? Traditionally, we were using clustering techniques such as k-means on the indicator data, or the latent variable scores were used to tap this unobserved heterogeneity. But this cluster analysis has got some limitation. It has got some flaws. The traditional clustering techniques ignores the path model relationships, and therefore we cannot apply the cluster analysis technique on the path model. It is very easy to apply for the segmentation, but we cannot apply in path model. So according to the researches which has been done by Professor Sarsted and Professor Ringel, the traditional clustering approaches perform very poor regarding identifying the group differences. So to overcome this, PLS-SAM has got some techniques which we will see later on. PLS-SAM applications usually analyze a full set of data, implicitly assuming that the data stems from a single homogeneous population, Zadari et al. 1997. The assumption of relatively homogeneous data characteristics is often unrealistic. It can never happen that you can have a one model for two different group of people. Or in other words, we can never have that concept that one size fits all. So the individuals or companies are different, and pulling data across observation is likely to produce misleading results. So according to the Professor Becker, Rigdon, Professor Sarsted, and Professor Ringel, failure to consider such heterogeneity can be a very serious threat to the validity of PLS-SAM results, leading to incorrect conclusions. And therefore, it is necessary that we account the unobserved heterogeneity which is there in your data. So acknowledging this limitation of the sequential approaches, methodological research in PLS-SAM has proposed a multitude of specific methods. Now, what do I mean by multitude? I will explain. to identify and treat unobserved heterogeneity. Two methods have been developed. One, the FIMIX, the finite mixer models. Another one is a prediction oriented segmentation. So these are two specific methods which have been developed. These techniques have proven very useful to identify unobserved heterogeneity and partitioning the data accordingly. These techniques are known as a latent class techniques. Now let us understand the difference between FIMIX and POS. FIMIX works well on structure model, POS works well on measurement model. FIMIX, I again repeat, it's a finite mixture model. POS is prediction oriented segmentation. FIMIX can work well on reflective construct. POS can work well on reflective and the formative construct. FIMIX works better with the formative construct having high multicollinearity. POS not better with formative construct having high multicollinearity. FIMIX works well on non-normal data. POS works well on normal data. Heterogeneity is expected to affect the structural model. In case of POS, heterogeneity is expected to affect structural as well as the measurement model. Now let us understand the whole concept of the heterogeneity. Say for example, if you run the model and when you get this path coefficient from y1 to y3 and y2 to y3, the path coefficients are p13 is equal to 0.30 and p23 is equal to 0.30. The source is the book PLS SAM, author Professor Hare, 2014. Now, if you split the data into group 1 and group 2, possibly P13 is 0.5 and P23 is 0.1. And in another group, P13 is 0.1 and P23 is 0.5. But when we aggregate the data, we get the average of 0.5 and 0.1, that is 0.3 in P13. And the average of P23, 0.1 and 0.5, we get 0.30. Now, if we fail to recognize the heterogeneity in above example which we have discussed between the groups and analyze the model using the full set of data, the path coefficient will be substantially biased. You can see here there is a biasness which has been introduced. Both estimates would equally approximate 0.30 when using the full set of data. Thus, the researcher to conclude that the price and quality are equally important for customer satisfaction, although they are not. Consequently, it is important to identify, assess, and if present, track the heterogeneity in the data. Originally, this concept was introduced by Hen et al. In 2002, and later it was extended by Professor Sarsted in 2011. FIMIX-PLS is the first and the best understood latent class approach to PLS-SAM. As indicated by its name, the approach relies on the finite mixer model concepts, which assumes that the overall population is a mixture of group-specific density function. The basic objective of the FIMIX-PLS approach is to disentangle the overall mixture distribution and estimate the parameters of each group in the regression framework. Or in other words, to do the mining of the data and to understand the model according to the groups, or to unearth the underlying pattern in the data according to the groups. So you can see here, this is the mixture distribution which is there. And FIMIX will work to identify the segment specific distribution. The procedures for running the FIMIX are: run the FIMIX-PLS procedure, step 1. Step 2, determine the number of segments. Step 3, explanation of the latent segment structures. Step 4, estimate the segment specific models. The first step is run the FIMIX-PLS procedure. There are several choices which have to be made in the algorithm settings of the FIMIX-PLS procedure. The model estimation in FIMIX-PLS follows the likelihood principle, which emphasizes that all the model parameters are selected because it works on the likelihood function. Finally, the PLS algorithm, the FIMIX-PLS algorithm needs to be run for alternating number of segments, starting with the one segment solution. Now, what is the concept? Let us try to understand. When we try to detect the unobserved heterogeneity, it may be possible that the heterogeneity may be scattered in one group, two group, three group, four group, or I will say one segment, two segment, three segment, four segment. And we are not aware about this distribution. And therefore, what we will have to do, we will have to run the FIMIX algorithm number of times. That is for segment 1, segment 2, segment 3, segment 4, and we will have to compare the result. So, as the number of segments is a priori unknown, the researcher is not aware because it is an unobserved characteristics. If it was an observable characteristics, nothing to worry. We will say male, female, two groups. Large scale industry, small scale industry, medium scale industry, three groups. But here researcher is completely unaware. So researcher must compare the solutions with the different segment numbers in terms of their statistical adequacy and interpretability, according to the Hensler 2014 and Sarstedt 2014. Now, a very crucial challenge for any researcher is in step 2, a fundamental challenge is determining the number of groups to retain from the data. So identifying a suitable number of groups is crucial because the managerial decisions are based on these results. Hare et al. 2016, defining a range of segment solutions to consider in the FIMIX-PLS analysis, has given a formula. The theoretically maximum number of segments is given by the largest integer when dividing the sample size n by the minimum sample size n minimum. So n upon n minimum. This I will explain in the next slide. Say for example, I want to find out the minimum number of segments. So this is the model which is there. This model is already there in the software itself. The first thing which you should calculate is find out the construct which is having a maximum number of items. So this is a model. Let us see this thing in a SmartPLS. We will study the example which is given, that is a corporate reputation. It may be possible that you may not be able to see the example this time. No need to worry. Click here in corporate reputation, install it, and the example will be installed. Double click on it and you will get the mod. Now I will have to identify the construct which is having a maximum number of items. 5, no, 4, 5, no, 3, 3, 3. Okay, the quality is having the maximum number of items is 8. Now, what is the second thing which I have to do is multiply by 5. 8 into 5 is 40. So the minimum cluster size is 40. So the minimum number of segments for which I will have to run the FIMIX is 200 divided by 40. 200 is a total sample size of the data. So 200 divided by 40. So I'll have to run the FIMIX segmentation. I will have to run it for 5 times. Minimum number of segments is 5. Now still there is another approach. The second method. Find out the construct which is having maximum number of items. Now let us try to take this for our example. I'll request all my viewers to kindly refer my previous video to understand the flow of this entire lecture series. In this model, the job satisfaction is affecting the staying intention of an employee. Organizational commitment is affecting the staying intention of an employee. Environmental perception is affecting the staying intention of an employee. Behavior of the co-workers is affecting the staying intention. I'll have to find out the construct which is having a maximum number of items. So all of them are having 4. And therefore, find out the construct which is having a maximum number of items is 4. Multiply it by 5. So 4 into 5 is equal to 20. So minimum cluster size is 20. Now calculate according to the G power. So this is the G power software. It is very easily available on Google. It's completely free. Just write down install G power. or download G-Power. Here, make sure that you activate this thing to the linear multiple regression fixed model single regression coefficient. Make this two-tailed and make this power size as 0.8. Calculate. And you got the answer to be 55. So this is 55. So according to the G-Power, the minimum cluster size is 55. Now, the maximum of 2. So the minimum number of segments is equal to 400 divided by 55. Now, there are some algorithm settings which we will have to see while running the FIMIX. Some of the settings which you will have to do are a stop criterion, ensure that a stop criterion of 1.10 minus 10 and a maximum number of 5,000 iterations is being done so that the segmentations can converge. That's the reason we are keeping so high iterations. Use 10 repetitions to avoid convergence in a local optimum. It may be possible that if you keep less number of repetitions, you will get the local optimum. So to avoid it, we keep more repetitions. Use the indicators having the missing values. Do not use mean value replacement or any other imputation method. Now, why this concept is that if your indicator is having a missing values, do not replace it with the mean or any other imputation method. The reason is that as soon as you replace it with mean, its standard deviation changes and therefore the density function changes and therefore possibly the segmentation will suffer. And that's the reason they have categorically told that please don't replace it. To define a range of reasonable segment numbers, use one segment as a lower bound. Always start with the one segment lower bound and the largest integer. That is rounding off to the largest integer when dividing the sample size by the minimum number segment size. This we have seen in the previous slide. So 1 to 8 we have to run. Now how we can run FIMIX in SmartPLS, let us see. So I'll go in calculate, activate the FIMIX segmentation. So here the minimum number of segments are 2. I'll start with 1. 5,000. Here it's 10 raised to minus 7. I can change from here. I'll keep the default settings which are there. Minimum number of repetitions are 10 so that it does not converge to local optimum. Everything else remains same. I'll press start the calculation. Now here, this model which is there, that is job satisfaction affecting the staying intention, organizational commitment affecting the staying intention, environmental perception affecting the staying intention, co-workers affecting the staying intention. I want to see that is there any unobserved heterogeneity or not. Observed heterogeneity, we have already studied in multi-group analysis in my previous video. Here we are trying to detect unobserved heterogeneity. But before that, we'll have to find out the optimum number of segments. So I'll click on open report. I'll directly go in the model selection criteria. And I'll have to copy this thing in Excel. So I'll press this copy to Excel. I'll activate the Excel file. I'll expand this. I'll write down here the criterion 1. Criterion. Okay. And this is for segment 1 segment. Now I will again run the FIMIX for 2 segments. So calculate FIMIX segmentation. Now I'll change the settings to 2. Start the calculation. Open the report. Model selection criteria. Now copy these results. Copy. Control V. Segment 2. I'll repeat this procedure 8 times because according to this method of identification the segmentation, we got 8 times we'll have to run the FIMIX. So again, I will go back, edit, calculate, FIMIX, and I'll go on changing this number 3, 4, 5, 6, 7, 8 and copy the results in Excel. So I have already generated the outputs for different segmentations. The criterions are Akaike information criterion. Now I have highlighted the value which is having the lowest value in the end, all the segments. You can see here. This is lowest. So segment 6 is having the lowest value. Therefore, it is highlighted. The logic is lower is the better. If I see AIC3, modified AIC with factor 3, here the lowest value is here, 939. AIC4, the lowest value is 962. Bayesian information criterion, 984. Consistent Akaike information criterion, 995. Hanen-Quinin criterion, 995. Minimum description length is 1114. And normed entropy statistics is 0.523. Now, all of these criterions are giving the different segmentation. How to resolve this conflict? So there is the approach which we will have to understand. If AIC3 and CAIC indicate the same number of segments, choose this solution, AIC3 and CAIC. So let us see, AIC3 is suggesting segment 8 and CAIC is suggesting segment 2. So we are not able to resolve anything here because there is a dispute. Okay, let's go to the next level. Alternatively, jointly consider AIC3 and BAIC. AIC3 is again segment 8 and BAIC is again segment 2. So this also we are not able to resolve. Consider the segment number as indicated by AIC4 and BAIC. AIC4 is segment 3 and BAIC is segment 2. Still we are not able to resolve. Okay. Generally choose the fewer segments that is indicated by AIC and more segments that are indicated by MDL5. Okay. Lesser than AIC. Lesser than AIC, so less than segment 6 and more than MDL5. So ideally your segment should be between segment 2 and segment 5. Okay, the last one. The entropy criterion should be preferably higher than 0.5. So you start from here. The first segment whose entropy is higher than 0.5, you will select it. So segment 2 is the optimum number of segments which you can go for. So you will have to study the heterogeneity for 2 segments. So these are the quality criterions on the basis of which we are selecting the segments. So these are known as quality criterions. So now it is very clear that we will have to run the FIMIX segmentation for segment 2 segments. So again, I will go back here, calculate FIMIX segments, and this time I will make it 2. So according to all the quality criterions, the minimum number of segments are 2. Start the calculation. Open the report. Now you will go in segment sizes. Segment 1 is a 0.851, that is the percentage. Segment assignment, it gives me the probabilities. That is the first case, 92% probability it is in segment 1 and 7% probability it is in segment 2. The same thing you can confirm from discrete segment assignment. These probabilities will be converted into the assignments where the cases are there. So these all are in first segment and this is in the second segment. Now this is an unobserved heterogeneity which has been identified by the software, and according to this software the model may differ. I'm using the word may differ according to this segment 1 and segment 2. We don't have this segmentation in our original data file, but we want to introduce this segmentation in our original data file. So I will have to add this segmentation in our original data file. Now this SmartPLS-4 has got the new feature. You can introduce this segmentation directly. How? You'll go and create data file and it will ask me that what you want to introduce. I will click all of them and create. Now what will happen as soon as I press create and when I will go in the original data, original canvas, the home page, the HBAT SAM, which was the raw data, now I am having also the FIMIX result. So if I activate this and when I go on the fag you can see some uh, new variables have been introduced. 1, 2, 3, and there is a final partition also which has been introduced. The final partition. You should take care of this final partition. Now I want to split the model according to this final partition. So what I'll do, I'll go in, generate the groups, and I'll identify where the final partition is. Here it is. I'll click on it and I will name this as FIMIX partition, or I'll just write down FIMIX, apply. So it's giving me that in the first group there are 382 cases and in second group there are 18 cases. Now I don't know that this grouping is done according to what. I cannot name it because it is an unobserved characteristics which is there, completely unobserved. If it in multi-group analysis we had seen that if it is 1 and 2 we are aware about the observed characteristics. We used to say 1 is male and 2 is female, but we don't know, we are completely unaware what this unobserved heterogeneity or why the model has been split into these two groups. So let us proceed further now. Now, as we are not aware about this unobserved heterogeneity, we will try to match this segmentation done according to the FIMIX. That is, in first, there are 382 cases, first segment, and 18 cases in second segment. So this unobserved, we are trying to match with some observed partition which can be there in our raw data. So I'll go in the raw data file. And I'll try to pick up those variables which are grouped or which are having an observable characteristics. So click OK. This is the same data which we are using in SmartPLS. You can see here that in this case, male and female are equally divided 50-50. This we had already studied in multi-group analysis, that how to study this observed heterogeneity. Here, geographic location class is also 200-200. But here, there is some amount of unbalance. That is, part-time is 191, part-time employees are 191, and full-time employees are 209. Now, deliberately, let us try to introduce the observed heterogeneity in our data. So again, I'll go in generate groups. The variable is C2, the employee class type. Generate the group, and this time we'll pick up C2 and we'll write down here employee type. Apply. So it's giving me the same result, 191 and 209. 191 and 209. Okay. And let us see the coding also, which is there for C2. So 0 is a part-time employee and 1 is a full-time employee. So 0, let us write down part-time. Apply. And full-time. Let us prefix that with observable characteristics. Okay, so we will be observable characteristics full time, and here also I'll write down here observable heterogeneity because of part time and full time observable. Apply. Now this is observed heterogeneity and this is unobserved heterogeneity. The basic objective is to compare both of them. We'll have to compare both of them. So what I'll do, I'll generate the results of both these groups separately. Now again, we'll go back and activate this. Make sure that the data set you select from here is FIMIX. Okay, then only you will be able to activate the partitions which are there. So you can select the data set from here, calculate, bootstrapping. Everything remains same. The new thing which you have to do is go in data, and first of all, you will try to study the unobserved heterogeneity according to the software. So FIMIX-1 and FIMIX-2, rather partition 1 or partition 2, segment 1 or segment 2, it's one and the same thing. Start the calculation. You can see here, this is a complete model. I can get the result for FIMIX-1, the model for FIMIX-1, FIMIX-2. Okay, the same thing I can report in a table format, open the report. This is for the complete data. FIMIX-1, FIMIX-2. I can also have the path coefficients. You can see here, at present, the complete model is on path coefficients for complete model. Now what you will have to do, copy this for reporting, copy this in the date in this format. So these are the paths, these are the original sample, this values which we are considering, this values, and just report the p value near to it. So this is a p value, right? Again go back. Now activate partition 1, copy this value. So partition 1 and its p value. Again go back. Now activate for FIMIX-2. Copy these values and the p value. So this is the FIMIX segmentation, unobserved heterogeneity. Now we want to activate the observable heterogeneity. So what we will do, again we will go back. We will have to do some small change in this data. Now instead of FIMIX-1, FIMIX-2, activate the observable full-time, observable part-time, start the calculation. You can see here the observable full-time, observable part-time. From here, click on open report, the complete path coefficients, the complete data, which is already there. This now you don't have to copy because this is already there. This is not going to change. The only thing is now according to the part-time and full-time. So observable part-time, copy this and paste it here, and its p value, full-time and its p value. So this is the way you can report FIMIX, and you can say that you can compare the unobserved heterogeneity with observed heterogeneity. Are we able to explain this segmentation or not, or is there still there is some another segmentation which is running? So are we able to explain considering this part-time, full-time, uh, the unobserved heterogeneity which is there, are we able to explain with our observable characteristics or not? So the results can be on both the sides. It can match also and it cannot match. So you can write the conclusion that still If it matches, then you can say that this observable character, this unobserved heterogeneity is because of this reason. Or you can also interpret this saying that the unobserved heterogeneity, which is there, the observable characteristics have not been captured, and therefore there may be the heterogeneity because of some another reasons. Another thing which you can report is, if it is a reflective measures, you can report Cronbach alpha of the model, rho, composite reliability, AVA. If it is a formative measures, you can report conversion validity, variance inflation factor, p-value. Now let us talk about this R square. R square, FIMIX segmentation gives you for different segments also. How? Let us see. I'll go and calculate again FIMIX segmentation data. Let us remove the sticks. FIMIX1, FIMIX2, start the calculation. So I will get R square, the adjusted R square for segment 1, segment 2, as well as part-time and full-time employee. That also I'll get. So I'll open the report and just click on quality criterion R square. You can see here the R square for segment 1 and R square for segment 2. And this is the overall R square. This also you can report here for segment for partition 1 and partition 2, part-time, full-time. Now let us try to understand the same steps again. Step 3 is explanation of the latent segment structure. This analysis is also referred to as a ex post analysis, which involves assigning each observation to certain segment based on the maximum segment membership probabilities. For example, if an observation in two segment solution has a 71 percentage of probability of belonging to segment 1 and 29 percentage of belonging to segment 2, one would assign the observations to first segment. This we have already seen. See, we had seen that we had tried to match this unobserved partition with the observed partition. So this is this step only. This process is also referred to as a hard clustering. It ensures that each observation is assigned to only one segment. Next, the researcher needs to partition the data using an explanatory variable or a combination of several explanatory variables, which yields the grouping of data that largely corresponds to the one produced by FIMIX-PLS. See, researcher needs to partition the data using an explanatory variable, which is a C2, which we have considered, or a combination of several explanatory variables, which yields a grouping of data that largely corresponds. Actually, here also the match is not perfect, right? You should try to figure out that observable characteristics which matches exactly or more or less nearer to this percentage. Okay, so that's step 3. The last step is, once the research has identified one or more explanatory variables that matches the FIMIX-PLS segmentation, the final step is to estimate segment-specific models as indicated by the explanatory variable. In doing so, the researcher must ensure that all the models meet common quality standards as documented. So, segmentation is fine, but we should also consider that the reliability and the validity of the model, the R square, and then only we can say that these partitions are optimum and we can consider these partitions for our study. So for more videos on SmartPLS, kindly subscribe to my channel. You can see my playlist in which I have already uploaded many videos related to SmartPLS. Please don't forget to press the like button. You can also follow me on LinkedIn and Twitter. Thank you.